Today we're going to talk about the active charge air cooling system developed by AirCycle Technology Limited. Most modern and high performance engines are boosted by supercharging or turbocharging, and they are critically dependent on the charge air temperature. This is the temperature that reaches the engine coming through the intercooler or charge cooler from the boost system. The charge air temperature can affect the performance due to changes in ambient temperature or vehicle speed, and is the basic limitation to the amount of power that can be achieved. If the temperature goes too high, ignition detonation can set in, so ignition timings require retardation, extra fuel needs to be put into the cylinder. So anything we can do to reduce the charge air temperature of a highly boosted engine will improve its performance and actually its fuel economy. The system we uses a turbo expander to create much lower temperatures than can be achieved with a traditional intercooling system. In fact, we can achieve temperatures even below ambient temperature. So we can greatly augment the performance of a highly boosted turbocharged or supercharged high performance engine. The core element of our design is a turbo expander. A turbo expander, as you can see, looks like a turbocharger, and you could think of it as an air turbocharger. It works in the same way as a turbocharger, but all on the air side of the engine. We have a compressor where we actually increase the pressure of the boost air coming from the engine's intercooler, which also increases the temperature. We then cool that coming out of our compressor with our own intercooler and bring the temperatures back down to about the same as the standard system. We feed that highly boosted air into our expander, our turbine. Going through the turbine, the air reduces pressure and drops temperature significantly. The pressure reduction is matched back to the pressure increase we had from our compressor, so we're back at the same pressure of the system. We get a big reduction in air temperature, so we can create cold air going into the engine, and that air can be colder than the ambient temperature. The system is self-powered because the turbine, in expanding the air through it, generates work like an exhaust turbine of a turbocharger. That energy is used to drive our compressor. So basically, the air we expand through the turbine produces power which drives the compressor, which compresses the air of our system. It's a very simple, effective system. The efficiencies are very high. We have a high-speed bearing system. We don't require an oil feed from the engine, so in terms of location, positioning within the engine compartment, it's very flexible, and it's a very sophisticated design and component.
For more details, please get in touch.